All right, this is the Math Models Unit 2 Lesson 4 video, and there's kind of two big concepts that they're kind of dealing with in this lesson. Um, they don't do a good job of explaining the first, but they do a better job of explaining kind of the second big idea. So I'm going to work through the problems and get you started on each of the problems in the lesson and kind of talk about the different concepts that they're trying to get across to you. So the first few questions are all dealing with either scale, the idea of a scale factor, or proportions being used to solve problems. So they start off simple and they get a little bit more complicated as it goes down the page. But like in number one, this is probably the most basic way that this problem can be asked. A baseball is 1.75 times the size of a golf ball. If the golf ball is 1.68 inches in diameter, what is the diameter of the baseball? The key phrase here is right here. 1.75 times the size of the golf ball. So right away, just based on the language they use, 1.75 times means that I need to multiply whatever the size of the golf ball is times 1.75 to find the size of the baseball. So I think you can get that one on your own. That's kind of the most basic way to use the idea of a scale factor, because this 1.75 is what we call the scale factor. It's telling me how much the dimensions are changing from the smaller to the larger, or from the first to the second example. Number two is very similar. Number two, it says we have a 3x5 photograph that's going to be enlarged to 150%. You should know that in algebra and math, typically when we're dealing with percentages, we're talking about multiplication. But more than that, we're talking about multiplication of a decimal. So if I'm going to use 150%, I actually need to put it into a decimal first. And that decimal will be the scale factor of this problem. So 150% is 1.5 in decimal form. If you don't remember how to do that, remember the basic idea here is that to find the decimal form, you take the decimal point and you move it 2 places back. So we end up with 1.50 or 1.5. So each of the dimensions needs to be multiplied by the scale factor, just like we did in the previous problem. Take the original size, multiply it times the scale factor, and that gets you the new value. Same thing here. Multiply 3 and 5, the dimensions of the original photograph, times the scale factor, 1.5, and that will give you the dimensions of the new size of the photograph. Then it gets a little bit more complicated. Number 3, you are building a house. The scale factor of the blueprint is 0.75 inches equals 2 feet. If the dimensions of the blueprint bedroom are 6 inches by 9 inches, how much carpeting will you actually require for the floor? There's 2 steps to this process. The first part of the process is to use the scale factor. And then the second part of the process is going to find the area of the floor. So we're going to kind of have 2 steps. So I'll get you started on the first step. So the first thing we need to do is find the scale factor. The scale factor is 2 feet for every 0.75 inches. So we need to do that in the calculator. 2 divided by 0.75. Let's hop over here. 2 divided by 0.75, and we get 2.66. So we'll use that as our scale factor. Okay, so I'm telling you right now the scale factor is 2.66. So you need to use that scale factor. You need to multiply it by each of those 6 and 9. So the scale factor needs to be multiplied by these. What you will get is you will get a new length and a new width from those 2 numbers. Then you need to take those and put them into the area formula for rectangles. The area formula for rectangles is the area equals the length times the width. Once you do that, that is this area of the floor that you are dealing with. So I didn't give you everything, but I kind of gave you kind of the flow of the problem. I think you can finish that from there. Oops, sorry about that. Let me saw this real quick. Okay, there we go. All right, a 5'6" student casts a shadow of 6 feet long. At the same time, a tree casts a shadow of 20 feet. So this is an actual proportion problem. So here we have the student. Probably should make that student smaller since the tree is definitely going to be taller than them. I have the student. And they are 5'6", also known as 5.5 feet. And their shadow is 6 feet. Then I have a tree. And the tree is casting a shadow of 20 feet. We don't know how tall the tree is. We'll call that X. So we're going to set up a simple proportion to solve this problem. It's going to look like this. The height of the person divided by the shadow is equal to the height of the tree divided by the shadow of the tree. Once we do that, we have to do cross multiplication. Write that down, cross multiply. Hopefully you remember what that is. Cross multiplication is when we take the diagonal values in the problem and we multiply them times each other. We'd multiply 5.5 and 20, 6 and X. They would be equal to each other, and then we would solve for X. So I'm going to let you finish that one out. You can simply Google cross multiplication if you need to see some examples. I think you guys will remember how to do that. But this is how this problem gets set up. All right, from here it actually skips to more of what the lesson was about, which is what the relationship is between the dimensions of something and its perimeter or its area or its volume even. And what happens when I say double the lengths of something? What happens to the perimeter? Does it just double? And we learned, they teach us some things. So I'm going to walk us through what those things are. So in general, when you start a new note here. When you multiply the dimensions of something, so let's say we multiply dimensions times 2, for instance, the perimeter, erase this actually. The perimeter also will be multiplied times 2 because the dimensions are a one-dimensional measure. It's just the lengths. And perimeter is also one-dimensional. But area is a two-dimensional. So if you're looking at the area of something and you've multiplied the dimensions times 2, you're going to actually multiply the dimensions times 2 squared, in this case times 4. So since the area is a squared measure, the dimensions being multiplied means the area is going to be multiplied by that number squared. Volume is a cube measure. So when I multiply the dimensions of something times 2, the volume gets multiplied times 2 to the third, in this case, times 2 to the eighth. So enlarging the dimensions of something yields more change the more dimensions you're talking about. So perimeter, it's the same. So if I multiply the dimensions times 3, the perimeter gets multiplied times 3. If I multiply the area times the dimensions times 3, the area gets multiplied times 3 squared, in this case 9. If the volume is multiplied, then it's going to be 3 to the third, or 27 times as large. So when we're dealing with this, first things first, we need to know in the problem I'm looking at, what are we dealing with? And in this case, we're dealing with perimeter. So it says here, the sides of one triangle are 3, 5, and 6. The perimeter of the second triangle is 42. What are the lengths of these sides here? Well, we can easily find the perimeter of the first triangle. We know the sides, 3 plus 5 plus 6. 3 plus 5 is 8, plus 6 is 14. So the question becomes, how did we get from 14 to 42? And with a little bit of guessing or checking, or just knowing your multiplication, we multiplied the perimeter times 3. And since perimeter is a measure of length, and the sides are a measure of length, we know that in order to get from this figure to this figure, we need to multiply everything times 3. So that tells me that, color here, 6 times 3, there should be 18. 3 times 3 is 9. 5 times 3 is 15. These 3 should be the dimensions of my new shape. It's very similar concept in number 6. So I'm going to leave that one to it. You need to lay everything out, figure out what it was multiplied to get to the larger, and then go back and multiply the dimensions to get that. Because perimeter is going to be multiplied by the same number as the sides. Now, number 7. First part, very straightforward. Find the perimeter and area of the picture. Remember, the perimeter of a rectangle is 2L plus 2W, and the area of a rectangle is L times W. Find those answers. Then it asks, what happens if we double the size, in other words, times 2, of the original photograph? Well, if the dimensions are being times 2, then the perimeter is also times 2. We learned that from our examples earlier. But the area is going to be multiplied times 2 squared. Times 2 squared. Should do it like this, sorry. So whatever answer you get here, multiply times 2, that gives you the perimeter of the larger photo. Whatever the area is, multiply it times 2 squared to get the area of the new photo. Pretty straightforward. Rectangular prism has a base length of 3, a base width of 2, and a height of 5 centimeters. What would be the perimeter of the base, the area of the base, and the volume? So perimeter of the base, this is a rectangle again, so you're going to do P equals 2L plus 2W. Area, you're going to do L times W. And for the volume, you're going to do length times width times height. You need to get the answers to each of those separately. Those are not the answer to the problem, though. You need to start by finding out what those answers are. Once you get that answer, you see here that it's been tripled. So the perimeter is going to be tripled. The area is going to be tripled squared, and the volume is going to be tripled to the third. So you need to multiply your answers from here times each of these numbers. For the perimeter, multiply it times 3. For the area, multiply times 3 squared, and for the volume, multiply times 3 to the third power. And that should be it. So hopefully I gave you some good information here. Best way to do this would be to pause the video as I go through each one. Make sure you got the answers before you unpause and move on. So I don't really have a good way of posting the things I'm showing you on the screen here, but make sure you are able to write everything down because on the quiz there are a few that are like these, and I think you should be good though.